You should have all been given an introductory activity sheet to solving trig functions. And the solving trig equations, part 1, talks about how we know that the values for sine theta, depending on what it is, we can have more than one angle relation to that solution. So we know that when we've been looking at triangles in Year 9, that of course all of the solutions we've been looking at are for angles between 0 and 90. But then as we start to introduce the unit circle, we look at values for solutions for angles where it goes all the way around to 360. We can also look at what are the possible values for anything. We could go for every single possible value we could find for sine of 30 or sine of a half, sine of theta equals a half. Or we could say, restrict it to this and tell me what solutions would exist within this period. So this is one of the questions that you've got under the single solutions, 0 to 90 degrees. You should be able to recognise that this is one of our really important triangles, right? That this is our 2, this is our 1. This will be square root of 3, of course. So you know that this comes from that 60-30 triangle. You should be able to write a equation. So if I'm looking at the 1 and 2, I'm going to use sine, because this is my opposite, this is my hypotenuse. So then I've got sine of theta equals 1 on 2. Now we should all recognise that, of course, that just means that theta is going to be 30 from our exact values. Since there is only one solution, we know that that's the only solution we're looking for, so we could then move on to the next question. For every single angle within the unit circle, there will be 2 solutions because that goes to 360. If I was looking at it like this, remember that it's all science teachers cheat. So in the first quadrant, I'll have positive, so I know that sine is positive in both the first and second. So I'm looking for 2 solutions actually for sine that are between 0 and 180. Now, if I'm looking at sine of 0.5, or 0.5 is here, is going to be 30 degrees, again from our exact angles triangle. If you're given a decimal where you don't know, it's not an exact one, then you're just going to need to use your CAS to find out what would be, right? Using your inverse sine function or inverse cos, inverse tan, whatever it might be. We know then the reference is going to fall into here. So this is 30 as well. So to get from 0 all the way around to this section, well, that's 180 minus 30, that's our reference. So we'll go 180 minus 30, which means I'm going to have 150. So sine of 150 is equal to sine of 30, which of course is equal to half. So if I was asked for what 2 values satisfy this equation, I can simply say that theta would be equal to 150 degrees or 30 degrees. And normally you'd put them in order, but it doesn't really matter for this case. If I then said, give me 2 more, what if it's between 0 and 720? I can just simply add 360 to each of those. And that's what we're going to do now in our next example. Okay, so what about if I still need to solve for 2 solutions, however, I'm given an equation like this? I simply have to use my algebra to rearrange my equation so that it's something that's recognizable to me, and then I can simply find the values based on my inverse cos, sine, and so forth. So if I'm looking at this one, I simply move the 1 over first, it's further away from the theta. So I've got 2 cos theta equals 1, becomes positive. Then divide both sides by 2, cos theta equals 1 over 2. So then if I wanted to use my calculator, if I wasn't sure, I just simply say cos inverse 1 half. But I of course know that it's going to be 60 because of our exact values. So in this instance, theta equals 60 in the first quadrant. Where else is cosine positive? It's going to be positive in the 4th quadrant. All science teachers cheat, yeah? You can even always just write this, all science teachers cheat, just to remind you. Then you can see that it's going to be in this quadrant. So if it's going to be in this quadrant here, then I just need to work out, well, the 60 member forms from the x. So if I look at it in this instance, and go, well, this bit here is going to be where my 60 is, right? So therefore, it's going to be 60 and 360 minus my reference. So it's going to be at 60 and 300 degrees will be where I'll find the solutions for this. The only thing is I've done an extra step into solving the equation first from what I did in the last question. Okay, so you can see then the next question after one, like we've just done, is a bit more tricky. You can have a go at this question and see if you can work it out, but it's not actually the types of questions that will be worked on for the test or the exam. We're more looking at the other variables and how they their implication changes when we're solving the questions rather than the multiplication in front of the theta. That'll just change the range and where angles come from. I'm happy to go over that with you guys in class, but I'm not going to put that on this. Rather than doing that, I would skip that question and move on to exercise 6.3 from the Pearson textbook, page 284, and have a go at those questions and see how you go, especially with question 1 when you're going through your solving, and then when you get to questions 3 and onwards, you can use the CAS to help you if you need to. I wouldn't worry too much about question 9, but you're welcome to have a go if you guys feel like you'd like to. There'll be 1 or 2 questions like this on the exam and definitely 1 on the test.